Hey mathematicians, how are we going? I want to talk you through the concept of congruent triangles today. So what I want to go through is basically looking at the fact that congruent figures are those with identical shape and size, and we're looking at triangles specifically. We want to explain that congruent triangles are triangles that have corresponding sides of the same length and corresponding angles of the same size. There are 4 tests of congruence in triangles, and to use those tests to determine if 2 triangles are congruent with correct setting out. So we want to review some stuff that we looked at previously, looking at transformations, reflections, and rotations. So there's 3 types of transformations that we'll review here. So the first one is a translation. So if we have a shape and we have the same shape, and you can tell by the length of the lines around the shape that it's the same. A translation is where each point in that shape moves across a grid the exact same distance. So if we look at this point here to this point here, that translation is 1, 2, 3, 4, 5 units across and 1, 2, 3, 4, 5 units down. And that's the same for the other 2 corresponding points as well. The next one is a reflection, and they flip across a line. So this line here is called our line of symmetry, and we can see that across that line of symmetry we have this point is 1 unit away from the line of symmetry, and this corresponding point is the same away from that line of symmetry. And we can take any points from that object, say this one and this one for example, and you've got 1, 2, 3 across, 1, 2, 3 across, and if they all correspond as we've seen down here, then that is called a reflection. A rotation moves around a central point by some angle. So this is angle A here, and we can have a 90-degree rotation. So we can see down here that point of angle A, we have this point and this corresponding point on the other shape. And if we measured that angle here with a protractor, that would be a right angle of 90 degrees. And you can pick any 2 corresponding points on that object, so this point, and we can have that rotation, and we can see that that's a right angle as well, which is a 90-degree rotation. So congruent figures have identical size and shape, and congruent triangles have corresponding sides of the same length and corresponding angles of the same size. So we've got 2 congruent triangles here. So we have side AB, which has 4.5 centimeters in length, and that corresponds to side XY, which also has a 4.5 centimeter length. Side AC has 3 centimeters, side XZ has 3 centimeters as well. And if we look at the angle between those 2 side lengths, so if I look at 4.5 and 3, 4.5 and 3, what's the angle in between that? That's that 60-degree angle there. So in between, that angle is a 60-degree angle there. So you can see this is a triangle that's just basically been flipped on its angle, okay? So these would be congruent triangles. And you can see that there's a 70 that matches up with a 70, a 50-degree angle that matches up with a 50. So an example question, are these 2 triangles congruent? So we have angle annotations by color, and we have side annotations by dashes in the sides. So we can see that there's a red, blue, green, and then the sides are even as well. But I guess to check, we need to make sure that the side lengths are in between the correct angles to show congruence. So if I was looking at this, I would be looking at the red angle and the green angle, and the side in the middle has 1 dash. So then on this triangle, I'd be looking at red, green, and that side has 1 dash. So that shows that they are actually the same triangles. And then we can see the proof that triangle X is rotated or reflected, so flipped on that line of symmetry, that mirror, and then it's rotated around so that this part goes down here, and then therefore we've got that same triangle. So the formal proof is saying if we reflect X and rotate it clockwise by 140 degrees, we will have shape Y. So therefore X is congruent to Y. That 3 dashes means congruent, which is saying identical. It's just been rotated or translated in some way. So we have 4 tests to show congruence. The first test is called SSS, which is side, side, side. And that's if we can prove that all corresponding sides are the same length. To write the proof, we need to list the 3 congruent reasonings with equals between the side names, each one on a new line. So if I'm drawing this one, I'm saying AB equals DE, so that would be AB equals DE, and they're both 4 centimeters. And my next one is BC. I'll try and get a different color actually. There we go. And then I'll say side BC equals EF. So BC, EF, and then side AC, sorry, new pen, new color. Side AC equals side DF. So AC is 3 centimeters and DF is also 3 centimeters. So that's my formal reasoning behind that proof. And my last sentence is saying, therefore, triangle ABC is congruent to, that equals with the 3 dashes, triangle DEF, and the proof is SSS, side, side, side. So the second proof is side, angle, side. So when you have 2 sides of equal length and the angle formed by the 2 sides, the included angle is the same size. Now this is really important, this included angle, and actually a mistake that I made when going through this in class today, which is really actually important, so I'm a bit embarrassed that I made that mistake. So the angle has to be the angle sandwiched in between the 2 sides. So to write this proof, you need to have 3 congruent reasonings with equals between the side names. So these 2 triangles here, to prove they're congruent, I'm going to say side AC equals EG. So if I highlight that on the triangle, that's AC, which is that 3 centimeter side, is the same as EG, which is that 3 centimeter side. The second line of the proof, the included angle, we're saying angle ACB. So angle ACB is this one here. So the middle letter is the one where the angle is, equals angle EGF, and G is right here. So they're both 50, which it shows on the diagram. Therefore, we can include that. And then the last one is the other side. BC equals FG. So that's BC, that's that 9 centimeter side, and FG, which is the 9 centimeter side as well. So that's our proof that the triangle ABC is congruent to EFG, and the proof that we've used is SAS, side, angle, side. So the fourth test is angle, side, angle, ASA, or it might be written as AAS. So you have 2 corresponding angles, so 2 angles next to each other, which they have to be in a triangle, and 1 pair of corresponding sides are the same size. So this corresponding is important. So basically what that means is the side that's identified needs to be next, needs to be the same side on the other triangle. So I'll show you what I mean as I go through this. So first of all, we can see these 2 triangles and we can see the angle ABC. So ABC, so this one here, 60 degrees. It's the same as this one here, so 60. So I can call that angle LMN, LMN. Okay, so the letter in the middle is where the angle is. The side that I have corresponding is AB equals LM. So let's just have a look at this here. I'm going to do this in orange. So AB is 10 and ML is 10. Now, importantly, that side is next to the 60 degrees and it is opposite the 70 degrees. Can you guys see that? So the 10 is opposite the 70 but next to the 60. In this one, the 10 is opposite to the 70 and next to the 60. So that's why it's a corresponding side, because that is the side matches up from the 2 triangles. So that's that word corresponding, which is really important. Lost my mouse cursor. There we go. That's that there. And then the last angle is the angle ACB. ACB equals angle LNM. So that's LNM. And therefore, triangle ABC is congruent to triangle LMN, and the rule or the test is ASA in brackets. The last test in this video is the RHS, so right angle, hypotenuse, and side. So right angled triangles when the hypotenuse and the pair of corresponding sides are equal size. So you need to have a right angle, first of all, and that's really easy. So for the first triangle here, we can see that angle ACB, so this right angle, is equal to angle XZY, which is also the right angle. And that is 90 degrees. So you can state that in this proof. And then we need to do the hypotenuse. Now the hypotenuse is the longest side of a triangle, which is the side that's opposite the right angle. So that's side AB and side XY, and they are equal to each other. And the last piece of proof is a corresponding side. So the 5-meter side AC here is next to the right angle and next to that side there. So it's kind of in between. And then in this triangle here, it's next to the right angle and next to that 12-meter side. So that's corresponding. So I can have that there. Therefore, triangle ABC is congruent to triangle XYZ, and your proof is RHS. So a summary to finish the video, there are 4 tests for congruence. SSS is you have 3 pairs of equal sides. SAS is when you have side, angle, side, and the angle has to be included. Don't make the mistake I made teaching this in class today. And then AAS is 2 pairs of equal angles and 1 pair of equal sides. RHS, both triangles have right angles, equal hypotenuses, which is opposite the right angle, and another equal side. Cool. Guys, thanks very much for watching. And my next video will have a couple of examples using these tests. See you next time.